Hi, this is Adrian from Live to Learn Academy, and today we're going to be going through lesson 8.1, exploring the logarithmic function. For those of you who are new to the channel, we post videos like this every Monday to Friday at 3 p.m. Eastern, so follow along, subscribe, and like the video if you see value. Without further ado, let's get straight into it. So guys, when we're talking about logarithmic functions, there's a couple key things we want to know, okay? First, I want to explain to you what an exponential function is. Okay, so an exponential function, let's look at the example y equals 2x, 2 to the power of x. Now, when it comes to this equation, there are 2 main points that I want you guys to know, okay, when it comes to exponential functions. The first point is when x equals 0, and the second point is when x equals 1, okay? These 2 points are going to help you graph an exponential function. So let's look at this graph. If we plug in 0 as x and 1 as x, what would our y values be? If we plug in 0, we get 2 to the power of 0, which is 1. And when we plug in 1, we get 2 to the power of 1, which is 2. So these are 2 main points on this exponential function. Another thing to note with exponential functions is that exponential functions all have a horizontal asymptote at y equals 0. Now, why am I explaining to you what an exponential function is? Because when you take the inverse of an exponential function, you actually get a logarithmic function. So if it's 2 to the power of x, the logarithmic function would be log base 2 x. So this 2 is called the base of the logarithmic function. So if that's the case, and we know that the exponential function is the inverse, then we also have 2 main points. Only difference is, what do we know about the inverse? Whenever we take the inverse of a function, we actually flip the points. So instead of 0, 1, this is going to be 1, 0. And instead of 1, 2, this is going to be 2, 1. Now, one thing to know about logarithmic functions is that in an exponential function, you have a horizontal asymptote at y equals 0, but in a logarithmic function, you have a vertical asymptote at x equals 0. Okay, so let's see how we graph these two. So if I look at, let's say, the exponential function, we have a point here at 0, 1, and we have a point here at 1, 2. I also have a horizontal asymptote at y equals 0. And what the graph is going to look like is it's going to hug this horizontal asymptote, and then it's going to swoop up like a hockey stick. This is what the function y equals 2 to the power of x looks like. Now, while we're here, we might as well find the domain and range as well. So the domain of this function is going to be x is an element of the real, because it just keeps going all the way left and all the way right. And the range is going to be y is an element of the real, where y is greater than the horizontal asymptote, which is 0. So remember, it's greater than the horizontal asymptote. For exponential functions, guys, you're always going to have x as an element of the real. That's always going to be the case. It's just the range changes depending on if the horizontal asymptote was shifted up or down in the question. Now, we'll get to those transformations later, but this is just a general concept of video. Okay, let's look at the inverse now. Remember, we know from functions that the inverse of a function is reflected over this line, y equals x. So remember, it's all reflected over y equals x. But we also know that we have 2 other points, 1, 0, and 2, 1. So, and the vertical asymptote is at x equals 0. So how do we graph this? For this graph, it hugs the vertical asymptote and then swoops out like a hockey stick like this. So this is our logarithmic function. log 2x. Now, let's look at this. We already have the vertical asymptote. We might as well get the domain and range as well. So the domain of the logarithmic function is going to be x is an element of the real where x is greater than the vertical asymptote, which is 0, because it's obviously everything to the right of the vertical asymptote. So depending on if there's a reflection or not, this could be greater than or it could be less than 0, but it's always going to be the right of 0 or the left of 0, and this 0 represents the vertical asymptote. But the range for all logarithmic functions is always just going to be y is an element of the real, because it goes fully up and fully down. So look at how the domain and range compare between the exponential and the logarithmic. For the exponential, x is an element of the real. But for the logarithmic, the range, y is an element of the real. For the exponential, y is an element of the real, but y is greater than 0 for the range. But then the opposite happens in the domain for log 2x. So this is the main concept, guys. This is the main concept when it comes to understanding these logarithmic graphs. All we're doing is we're taking the inverse of the exponential function, we're flipping the points, and then we're graphing the function. So if you found this video helpful, right, feel free to share it to your friends if they're confused about logarithmic functions. Feel free to save this video, subscribe to our channel, and I'll see you guys in lesson 8.2.